科学与大数据分析。但是我能够保证你们一件事情，就是你们只要努力付出，你就会得到你要的东西在这方。这是我可以保证的。你只要负责努力就好。真的吗？真的，我没有骗你。啊？学校能不能无缘无故放2天假？有啊，要假期啊。10月中有个假期啊，11月有2个假期。我们现在10月了。10月有假期没？有。未必哦，那个假，那个票假。讲这个那呀，不知道是吗？它是 Taylor 还是什么？好像 midterm 结束过，还有放在1个礼拜了。哦，对，厦门是没有 midterm， 对啊，然后我弟还有他们那种说没有 midterm break 了呗，啊，我们是有时候 midterm break 这种非常很chill的。总共上几周？我听说他们总共上14周加买休息的那一种，所以呢，都是他们要组织。但是我们有15周吗？就是他们老师有帮，所以我们不仅课多，休息时间还少。赚。那场上面100K bro， 不要玩，贵啊！我去直接领快，不用讲那么多。Okay, start. Okay, so I think we will postpone the assignment time probably to Friday midnight. Okay, Friday midnight. Yeah. Because we can't finish the syllabus. Can we use answer book? What do you mean answer book? What answer book? What type on the board? The book where I write answers now. I mean this file full of answers instead of the questions. No, I mean you need to write your answer or solution. Yeah. So I write all the answers in the book without the question, just the numbering. Yeah. I cannot. Yeah. So what's the problem? What's the problem? I don't understand. What's that? Oh. Yeah, no problem. No problem. Yeah. I mean, you don't need this cover page also can. If you like, you can. Yeah. Okay. How's mathematics important? Have you guys seen this or not? Yeah. Huh? Oh. What's the tool name? Shape of U is from divide. Okay. Plus minus equals to divide, multiply. So the name of this tool is a mathematics tool. Wow. X-Sharon concept. Yeah, you guys know X-Sharon or not? Yeah. Okay. Share of you, huh? Share of you. Yeah. Okay. So yeah, right. So if you experience that this class is hard, you are right. You are right. You have the right feeling. Okay. So what can you do? Is to work hard. If you work really, really hard, you will get what you deserve. I will promise you. Okay. Yeah, I definitely promise you, you will get what you deserve. Okay or not? Okay. Yeah. Please don't expect me to I'll say do what the other lecturers do. Okay, I'm different. Okay, yeah, I'm different. The reason I came to here is because of pure maths. Otherwise, I won't teach because I know the standard of Malaysia is not good enough. Frankly speaking. Okay. Because here offer epsilon delta. That's why I come here. This is the only thing I ask for.
Since they do it, then I come. They don't do it, I won't come. I don't want to teach normal linear stuff. I rather do other work. That's why I come. Okay. Yeah. So if you have any question, don't hesitate to find me, contact me. Okay. Or if you want to ask Larry, also can. Yeah. So you just feel free to contact me. Come to my office hour. Okay. I know that the student here doesn't have practice or habit to find a lecturer, right? Okay. So you can develop it. When I was studying, I always go to lecturers office hour. Maybe there's only me with the lecturer. Yeah. So for example, there's a course is called analysis. So analysis is what you will get after calculus. That course is really, really hard. Every time I will go to the lecturer office every week until the lecturer know me. Yeah. He didn't explain well in the class, but I still approach him. Okay. That's the only help I can get. So I go and get it. Still, he explained to me, I don't understand. But I just sit there and listen and listen and listen. Still, I don't understand. That semester, I don't understand. But after about 1 year, only then I realized what I'm studying. So the study process really takes time. Okay, don't think that now I don't know, then I give up. Please don't give up. You will get it later. Do you get what I said? What did I say? Okay. Okay, good point. Good point. Okay, don't give up. Just don't give up. Okay, good point. Yeah. Yeah. So last semester, if you like approach last semester student, they are experience the pure math side now. Yeah, they also feel it very hard. Okay, and then a very how to say grateful things is they sent me something. They sent me that in the analysis class, seems like I saw what your question before. So like I expose things earlier to them. Yeah, so that when you go further study, you will think that this one seems like I see it before. I know it. Okay, instead of wow, so hard, so hard, so hard, every time so hard. Right. Okay. Yeah. So I try in my class, I try to expose something harder, okay, but it's not it's workable. Okay, workable. So meaning you can derive. Do you guys read my assignment solution or not? You guys read? No. Huh? Don't have time. Hey, this is a good place you learn, you know. You learn how I explain the answer. And then compare to how you explain the answer. Right. Okay. So usually lectures assignment is where I learn how to do the question. I see, why the lecture answer is shorter than mine? How can I improve my solution? Right? Yeah. I also realized last semester the student didn't do it. So they can't quite get what I say. You know, there's a problem with mathematics students. Why I don't want to give textbook question? You know why? Because they come to class, they don't listen. You know why? They don't listen. Because they know when they go back, they just follow the textbook and do it. They don't know what they are doing, you know. They really don't know what they are doing. Because now we are doing pure maths, okay? And then they write down something they don't know what is going on. I ask them, who write this? No one answered. Then I pull out the assignment and ask, whose handwriting is it? Only that person know what is going on. He saying what? He saying, I copied this from Google. He don't know what he's writing down. You know, this is the problem. Okay, study maths is not just copy paste. follow instruction. You create instruction. You know, you are the one who create the rules. You are not the one just following rules. Of course, you need to be able to follow rules first, then you create rules. Okay. So the level you want to get from this maths degree is you are the ruler. Not the ruler, but you are the one that create the rules. Not just following rules. You know why they create these rules. And then how this rule can be changed to make things better. Seriously, this is what pure maths can give you. I told about this to the previous class. They don't appreciate because they just don't care. I'm not sure how to make them care, but I'm still working on it. I think there's still how many weeks now? 6 weeks, 6 weeks. Maybe there are 9 weeks. I think it's the most time I can spend with them. I think maybe I won't see them anymore. Yeah, because most probably most of them will go apply. Yeah, so it's okay. You go apply or pure. It's okay. Never mind. But the problem is what you gain from the course. What you gain from studying. Okay, I don't want to just wasting time come here and then copy answer or learn something that is obvious, right? Okay. If you feel hard, that's right feeling. Come and get help. Come and get help. Okay. Don't complain. You can complain, but work again. Yeah. Don't stop working. Okay or not? Yeah. But in general, your class I think is better. At least from where the attitude, actually it's the attitude you guys put into studying, into class. It's different. It's really different from them. Their class every time will have someone disappear. So it's not consistent. Okay, so the attitude is different. So make sure you keep the right attitude. Then you will achieve what you want. Okay, otherwise you just live a miserable life. Yeah. Okay. 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 So make sure, because my stuff is very hard, so really need to get feedback from you guys. Okay, like my lecture notes, is it clear or not? This part clear or not? Last semester I have 2 classes, right? One of them is AIT. For the AIT students, they will ask, why are you talking about in this part? Okay, why you write like this? Why this one is like that? Okay, and then they did better. And then 2 of them get 100 marks in the final. Of course, their question is mostly calculation, but still, right? Still getting 100 marks is a challenging part. Okay, yeah. So make sure you clear any question doubts with me. Okay, yeah, and then I will give back the feedback. Okay, can you can play, but you have to arrange your own time. Okay, study time, play time. Don't procrastinate. And then rest well. Okay. Yeah. Okay, let's continue. Let's pick up from where we left last time. So last time we talked about how to create a line. How to create a line. How to create a line. I mean, how to describe a line. Yeah. Good. Very good. So you need to know a point on the line, okay, with a tangent. Okay, then you can draw this line out. Okay. So for example, this point is x1, y1. Okay. Then this line will be described by y minus y1 times the m, okay, times x minus x1. So what's m here? So m is the slope. Okay, dy dx. Okay. Yeah. So where did we stop last time? So we start with an example. So curve C, okay, defined by the parametric equation, okay, called x equals to t squared, y equals to t cubed minus 3t. So last time I said, what's the advantage of using this parametric equation? What's the advantage? What's the advantage? Let's see. Why we introduce an extra t variable to describe plane curve? You find a helper. Okay, find one. Find one. You find, I find you. I find you, right? Who is Eric? Oh, Larry. Okay, your teacher. Okay, sure. Okay, Larry.
We can treat it as two functions, and from that we can perform our previous calculus knowledge on it.
Treating it as a two function. Okay. So what's the advantage of doing that? Yes. Wow, I think your memory is quite good. It's quite good. Please use it well, okay? Use it well. So, uh,
Problems
mhm.
where it previously exists on the functions.
So what problems? What problem exists on the function? For example? Correct. Okay, correct. Okay. So for example, if you cannot describe your curve with a function, okay, y in terms of x, then you need to introduce this extra t, because you use different t to go back to the same point. Okay, you use different t to go back to the same point. Okay, so you are actually introduce a third dimension. Okay, you introduce a third dimension into it. Okay. All right, good, very good. So last time we have this example here, and then we figured out there are two tangent. So there are two tangent line at 3, 0. Okay, there are two tangent at 3, 0. So we find them last time. So one point is at t equals to square root 3. The other one is t equals to minus square root 3. Okay. And then the first one we get is y equals to square root 3 times x minus 3. And then when t equals to minus square root 3, we get minus square root 3 times x minus 3. Okay, so we can try and draw this. Actually, we can draw this, right? We can try and draw this. So let's get the point 3, 0 here. Okay, so we have two tangent. One is square root 3, one is minus square root 3. So they are forming a x at the point 3, 0. Okay, you have forming a x at the point 3, 0. So you have an x here. Okay, so which one is for t equals square root 3? So it's the one that is going from left bottom to right top. So this is t equals square root 3, and this t equals square root. Okay. So you need to start guessing how this curve comes in. Okay. So your curve go around, right? When t equals to square root 3, it touches this tangent. Okay. Either like this or either like this. Okay. And then when it's before that, when t equals to square root 3, it is either like this or either like that. So let me draw something here. So you are either like this or you are like this, or at t equals to square root 3, you will get something like this. Okay. So somehow you need to connect either two of them. Okay. Somehow you need to either connect two of them. So for example, maybe you get something like this, perhaps. Something like that. Who knows? Okay. We don't have more information. So the most thing you can do is how to connect either two of them. Right? One at t equals square root 3, one is t equal to minus square root 3. Okay? You get what I mean? Yeah. Yeah. Okay, so we need to get more information to draw this curve here. Okay, so let's get some more point. Okay. Let's get some more point. So let's find the point on C where the tangent line is horizontal or vertical. Okay. So what happens if it is a horizontal tangent? What do you think? What does it mean by horizontal tangent? Yeah. The slope is 0. There's no change in height. Okay, no change in height. So for example, horizontal tangent is like this. Okay, so your curve is like going up and down. Okay, so no change in height. What do you get? You get dy dx equals to 0. But how about dy dt and dx dt? Okay, dy dt should be 0. Okay, because no change in height. But ds dt is not 0. Okay, because otherwise, you see, last time we have shown that by chain rule, dy dx is dy dt times dt dx. Okay, yeah. Okay, so then what? Then, okay, then let's get some point out. So let's check where dy dt is 0. Okay, so what's our y? So let's get our y out. So y equals to t cubed minus 3t. Okay, so we differentiate this, we'll get 3t squared minus 3. Okay, and then let this equal to 0. Okay, let it equal to 0. So we will get that 3t squared minus 3 equals 0. In other words, t is equal to plus minus 1. Okay, t is equal to plus minus 1. All right, so meaning what? Meaning at t equals to 1, okay, t equals to minus 1. Maybe you want to put second there, it's fine. Where's the point? Okay, we need to get the point out. So meaning we need the x as well. So what is our x? 3t squared. Okay, I believe you. So when at t equals to 1, what is x? X is just 1. Okay, how about y? Y is also minus 2. Okay. So we get the point 1 minus 2 here at t equals 1. How about t minus 1? Okay, t minus 1 is what? X equals to 1 again, y equals to 2. Okay, good. So we have 1, 2, when t equals to -1. Okay, so this is the horizontal tangent. How about vertical tangent? Okay, how about vertical tangent? Vertical tangent means there's no change in x. Okay? No change in x. What's the dy dx? No. Yeah. So why is it infinity? How to deduce? Why is it straight line? Okay, so let me draw this vertical tangent, right? So wait, let me draw first. So vertical tangent is something like this. Okay, no change in x. So why is it dy dx is infinity? Okay, good. Very good. So does everyone got what he said? So okay. Yeah, okay, let me repeat what you said. So for example, okay, you consider this line here. This is y equals to x, right? Okay. So the gradient of y equals to x is 1. Okay. How about I change the gradient to 2x? What happened? It becomes steeper. Okay. And then you consider 3x, 4x, 100x, million x. Right. Then you will approach the vertical line or the y-axis. Okay, so you get the gradient is getting larger and larger. Okay, so at vertical tangent, actually your dy dx is approaching infinity. Okay, so this implies what? So your dx dt should be 0. Actually, it's not implied, but dx dt is 0. Okay, but you have some change in y. Sorry, why am I writing? Sorry. Some change in y. Actually, this is actually very important. Very important here. Because you can think about what happens if dx dt is 0, dy dt is 0. This is a different case. Okay. So you need to make sure the other one is non-zero. Only this tangent will pop up. Okay. If two of them is 0, is a different case. Anything will happen. You will see example maybe in future. Okay. So then what? Then let ds dt equals to 2t, let it equal to 0, and then we will just get the point t equals to 0. Okay. So when t equals 0, where's our point? Okay. It's just x equals to origin, x0, y equals to 0. Okay. Yeah, it's the origin. Hey, by the way, who is the other girl sitting there always? I know Yan Ru cannot come. The one with Yan Ru. Sydney, oh. And who is the yeah. I think the one that's sitting with Sydney. Yan Ru. Is it Sydney? Oh, Roland. Who is Roland? Roland, right? Sydney Roland also. Okay. I know Yan Ru got a appointment, but I'm not sure about the others. Okay, so what do we have here? Okay, let's collect what we have. So let's redraw our graph again. Redraw our graph again. So we have t equals to square root 3, t equals to square root minus square root 3. And then vertical tangent at t equals 0 at the origin. Okay. Am I drawing somewhere wrong? So I should shift this. This is a 3, 0 point. Okay. So where's my vertical tangent? So my vertical tangent is on the origin. And like this. So this is when t equals to 0. Okay. And then we have horizontal tangent, okay, at 1, -2, and 1, 2. Okay. So 1, -2, and 1, 2, where is it? So let's say 1 is here, and then 2 is here, and then -2 is here. Right. Okay, let's check first. When x equals 0, this is 3 times square root 3. Okay, so this is higher. So that's fine. Okay, so we have 2 tangent lines here. Okay. So from these tangent line, right? So can you guess any interesting curve that you can get? So how about let me draw some possible curve that we should get. Okay, something like this on both of these. Something like this here, then here, and then on the other side here. Okay, so can you join them or not? Can you join them or not? Okay, so where is this time for the horizontal one? Okay, so for the top one, we have t equals to -1. Okay, for the bottom one, we have t equals to 1. Okay, so what's the order of touching these tangent line? Do you know? What's the order? So we start from negative time. Is -1 bigger than negative square root 3 or not? Square root 3 is smaller. 1 point something something is it? Okay, so we start with t equals square root 3. Okay, so first place you should touch this either one of these. Okay, and then you need to touch -1, and then you need to touch 0, and then you need to touch 1, and then you need to touch square root 3. Okay, can you imagine? Can you try draw some meaningful curve from here?
Ellipse.
Eclipse. How does eclipse look like? You mean something like this? Eclipse. Yeah. You want to try? Try and draw. Try and draw. I give you 3 minutes. If you can fix one line out, and you show me. And then later we'll decide which line is the good one. Yeah, try and join 1, 2, 3, 4, 5. 5 of them. Let's see if you can get some interesting line or not. Yeah, try draw on your paper or what. Try draw on your paper. Try draw on your paper. See if you can match some interesting curve. I think there are quite a lot of possibility here. Maybe. Try draw one. Give you 3 minutes. Try and draw one. And then we will discuss your choice. Try and draw one. Draw. Try and draw one. Once you have got it, show me. And then we can discuss whether it's possible or not. For every tangent, you have 2 choices. Okay, but you can only meet once. Because these are the points we found. I draw on your exercise book and show me. Try. Try. You need to move your hand. Cannot just think. You need to move your hand. One already got some picture. Move. You need to move your hand. Move your hand. Yeah, question. What do you mean by time? Which one? This one? This one? So what does it mean by tangent line? Tangent meaning you need to touch this line tangentially. You get me? So these are part of my curve, possible part of my curve. So my curve maybe wander around, but when it go to here, it must touch it and then go away. This is the meaning of tangent, right? What's the tangent? What does tangent mean? What does tangent mean? The curve, 1 point. Yeah, so what's tangent? Yeah, so what's tangent? What's tangent? What's tangent line? How to define tangent line? Okay, let me give some example, right? So, okay, let's figure out what's the tangent line definition. So, you see, let's say I want to find a tangent line here. So the tangent line here should be something like this, right? Okay, but if you extend it, it cuts through the curve a few times, right? So what's the definition of tangent line? So tangent line at the point is the line with the gradient at this point. Okay. But how you realize this tangent line geometrically? So if you zoom in enough, okay, this line will only touch the curve at this point. Okay. So this is what I'm recovering here. So if I zoom in the curve enough, the curve will touch at this line, either like this or like this. Correct now? So that this will be the tangent line of my curve. So we are finding vertical tangent, horizontal tangent of my curve. Okay. Make sense or not? Does it make sense? Does it make sense? So, yeah, sure. I mean, you can think about it, but if you are skeptical or suspecting what am I saying is wrong, you should point out. Okay, anyone try out? Any curve? Yeah. Anyone try out? Yanker. Is it Yanker you? Are you Yanker? What's your name? Oh, Guan Ye. Have you tried? Can you show me? Okay, can you send to my teams? Send to my teams. Let me show the rest. The other you can keep drawing, keep drawing. So let's discuss whether the answer is possible or not. Send to my team, forward the image. How about the rest? Anyone think? Zhongyi finish or not? Try? Haven't tried? You tried? Huh? You managed to connect 5 lines or not? Not yet? You? Send me there. Let me see first. Done. Wait. Okay, send me. Huh? Yeah, send me, just send. How about the rest? Anyone done? Yeah, just get one and then send me. Then we will discuss. Still got question or not, Senjek? Just ask, never mind. Ask the same question also can. How I get t equals to -1, t equals to 1. Okay, just now I computed, right? Where does horizontal tangent happen? Yeah, so if it happens at t equals to 1 and -1. And then you start t equals to -1 and then check where's the point. Right, your point is controlled by time. Your point is controlled by time. Okay, yeah. This is the parametric equation. Okay, described by time. Okay, Kwanye sent me a message. Okay, let's have a look on this piece of art. She named it a kidney. Okay, let's see this kidney. So, you see, does it match all the tangent line or not? You see, 1, 2, 3, 4, 5. Good. Again, measured all the tangent line. But any issue here? So the issue here is you created 2 extra horizontal tangent and 1 extra vertical. Can you guys see or not? So there's a vertical tangent here and a horizontal tangent at the in the smaller circle. Sorry. To close it, huh? No, it's fine. That's fine. Ron is fine. It's okay one. It's okay. Never mind. Nothing. How to say? Yeah, I'm not like. I'm just trying to discuss the possibility. It's fine. Yeah. Huh? So you need to decide where does the endpoints go, right? You need to decide where those endpoints go. Okay. So it's okay to make mistake. So what's the problem with this graph is you created 2 extra horizontal tangent and 1 vertical tangent. Okay, but what we computed, there's only 1 vertical tangent and 2 horizontal tangent. Okay, at exactly 3 points. Okay, because we only find 3 times, right? 3 times. 1 at vertical, 2 at horizontal. Okay, so we need to somehow modify this part here. Okay, somehow we need to modify the small circle. You get the reasoning or not? Do you get the reasoning? Okay, this reasoning is what I want you to learn from the way the pure math studying this kind of question. Okay, we need to start reasoning whether it is possible to happen or not from what we have. Okay, from what we already know, we know that this is not possible because this created more horizontal and vertical point. Okay, from what we know, there's only 3 points, 1 for vertical, 2 for horizontal. But here we have 6 times that meet horizontal and vertical. Okay. Okay. Yeah. Can you send me your? Yeah, send it to me. Hey, Lohao send one. Is it? Lohao send one, is it? Okay, let me see. Let's look at Lohao one. Okay, So how got this picture? I think this is almost the same as Hang Wei one, right? Is it similar? Similar? Same direction? Okay, so let's look at this picture here, right? So you have horizontal tangent, good, you meet one, vertical meet one, horizontal meet one, and then t equals to minus square root 3 and square root 3 you also meet once. Okay, good, everything mixed. So we need to check whether this is true or not. Okay, let's check whether this is true. Okay, how to check? So the next part is, I think you learn concave up and concave down, right? Okay, how to check okay, so let me define the word first before we talk about how to check. So determine where the curve is, oh, sorry. Okay, so let's determine where the curve is concave up or down. Okay, so for those who forgot or not sure what it means, so what is concave up? Okay, how does the curve looks like? So concave up is something like this. So concave up. So you go down and go up. Concave up. Okay. And then how about concave down? You go up first and then you go down. Okay, concave down. Okay. Okay. So you how to remember this? So you remember what happened at the end. Okay. What happened at the end? So you have to go up. Or you have to go down. Okay. What happened in the end? Okay, remember what happened in the end when you walk along this curve. So first, concave up means d2y dx square is greater than 0. Okay, and then concave down is d2y dx square is less than 0. Okay. Okay, so we need to deal with second derivative. So last time we introduced how to calculate this number, d2y dx square using chain rule, right? Okay, dt on dy dx divided by dx dt. Okay, so why we do this? Why do we do this? Because we need to introduce a new variable t. Okay, we introduce a new variable t. So everything need to differentiate with respect to t. Okay. So what to do? So have we computed what is dy dx yet? I think this one is from last week, is it? Okay. From last week, we get that dy dx is actually 3t squared over 3 over 2t. Okay. If not, how you get this? You just take dy over dt divided by dx over dt. Okay. Okay. And then dx over dt, from the answer here, you also can get that it is actually 2t, right? So top part is dy over dt, bottom part is dx over dt. And you just do the differentiation. Okay, so how do you do the differentiation here? Maybe you don't want to go into quotient rule. Okay, don't get backward for yourself. You just split this into 2 terms and then differentiate term by terms. Okay, what do I mean by that? So instead of doing quotient rule, you can just split it into 2 terms, which is 3t over 2 minus 3 over 2t. Okay, so you will calculate faster. Okay, so after differentiation, you will get, okay, first you get 3 times 1 plus 1 over t squared over 4t. Okay, to make it nicer, you multiply by t squared on both numerator and denominator, you get 3 times t squared plus 1 over 4t cubed. Okay, so what does this tell you? What does this tell you? Okay, when this number is greater than 0 or less than 0? When does this number greater than 0 or less than 0? So when d squared y dx squared is greater than 0 or less than 0? When? So the numerator is what? It's always positive, right? T squared is always positive. Plus a positive number is still positive. Multiply a positive number is still positive. So the really that control the positive and minus sign is the denominator. Okay. So when does it? So the numerator, let me write down the numerator is always positive. Okay, because you have square, you add, you multiply with positive number, add with positive number. So when does when does d square y dx square less than 0? When d square y dx square less than 0, t must be less than 0. Okay, and then similarly, when d square y dx square is greater than 0, t has to be greater than 0. Okay, good. Very good. Okay, so meaning what? So when is it concave down? So concave down is less than 0. So this part is concave down. So concave down means you go up and down. And then when t greater than 0, you concave up. Concave up means you go down and up. Okay. So let's take a know-how picture again. So remember what have we said just now? So okay, how about I download this better? Let me download first so that I can share the screen together. Okay. Okay. Okay, good. Okay, we can see both. Okay. Can everyone see clear what's going on? Okay. So where is t less than 0? T less than 0 is on this part here. So t equals to -1 on this line. T equals to square root minus square root 3 is on this line. Okay, t equals to 0 is here. The origin is here. See the cursor. Follow my cursor. Okay, so this part should be less than 0, so it should be concave down. Okay, so you can see that the concaving down is this part here. Everyone see it? Okay, so where is it t greater than 0? T greater than 0 is 0, 1, this tangent line, and square root 3, this tangent line. So it's about this part here. And then this part we said that is concave up. So you go down and up. Okay, so you move from negative infinity all the way up, and then you leave for infinity again. Okay, so that's the direction of this orientation on this curve, which is from the bottom to up, and then you will follow this line all the way. Okay, makes sense or not? Okay, so what we are doing here, this is like illustrating you the idea of calculus. We look at the local property. We look at tangent. Where does the tangent happen? And then I recover the whole curve for you. Okay, so this is the idea of calculus. Yeah. Right. So we are like working backward. At first, you know the curve. Okay, you can draw this tangent line. But let's say I only tell you tangent line. Can you tell me the curve or not? So this is what we did. Now, I only tell you tangent line. Can you recover the curve for me? Okay. So you should imagine if we go to higher dimensional, how much more derivative we need to know. So this is a 2D case. Okay, 2D case. We need to know what is dy dx. We need to know first derivative. We need to know second derivative. Okay, then it's enough to draw the circle. But if we go to higher dimension, how many derivatives we need to know? Okay. So to n dimension, we'll study n derivative, for example. Okay. Okay. Right. So this is the right picture we have for this example here. Okay. So any question or not? Any question? So far, okay. So far, so good. Let's take a break now. Okay, let's take a break until 4:12. Okay. You try one.因为他晕掉，他课了2个星期，我跟他睡了2个星期，跟他入眠，所以如果他改变了我门口，你入眠。我们是进来 registration 的时候，我们也是赶在一个。因为我们那去玩过，对，有。没有，我们希望这些会超出的。会。来他们，多来二十多。有。I mean, such a I'm with me on the wise. 我本来以为是在 FUT 就是意见接受，理解接受。原本也是扣很久嘛，是要先从这边画。你这个有太不画，一边要画完。哦，你看到？它是从这边。明白。因为怎么样？是从这个，我就不讲转回去了。一来你转回来，你就有一个新的本格。回来你就要有一个本格。然后其他的我都以为都有交集，像这里也是有交集的。你可以本格嘛？因为我只有一个少号的，就一个是。对，到属于啊，你可以 try 一下不同的方法，你可以造出新的。
像这种客户都可以都跟新的吧？那这种偏见那种可以出新的，不是只有一种。
没有比如说刚才那个 example，如果你造一个新的圆圈的话，你就会造出新的圆圈。
这个道理。
我们
所以是这些，虽然讲，要我有更多的研究呢，那不像这些。
一个房间起码你条件越多，你的挂的东西就越少。
现在找
越多条件，
只要说
越
现有的大爱豆不去看车上，没有，
有
三个，
就越少量，因为你越多条件，可能性就变少了。
越少越好。
越少条件可能性就越多。
如果你驾车过去的话，大概要
像是不能估也是拼。
如果你大车过去的话，好像也是一个，你可以穿。如果你走过去的话，
这个话，但是我
这5个顺路。
你们都是坐车的。
如果说是那天一大去苏曼可西，我在从苏曼可西大去是40分钟，再加个几分钟，可以。
厉害吧？厉害吧？
厉害。
都自己甩这样。
对。呀，它全部都是下山加它
移动完那个周五，
它都是
不，我们看移动完那个好还有地方，回来一个移动嘛，是的吧？
你的会员是哪个公司？
就是到那个
是不是到？是不是到？
对，大城堡有的，
对，有啊，我们那个 line 特别短暂，我们那边 line 特别短暂，
有的是超级野，就可以考虑上次去吃海底捞，就有一个台湾
没有，
都可以了，
反正他们也会踢过了，就是这路的反方向没加去。
看了头，
就是完全不知道名字的时候，你看知道是不是？我完全不知道有这个。
好类似家，有啊，就是这都偏那少的。
不角度的些，它是我不完整的。
应该不能够太完整了，只要它 content 足够多。
这样还有就是，比如说，
谁来做哦？我要对，
还是大家有，就是现实里，
妈，变成越来越快，好。
但是我是想说，就是你不能够走到
看着非洲还挺大的，
大多数人都会达到不同的，所以你不能够说比较懂事，他可能到点。
你这样
可以的，然后就是大概学一条比较可能就不要说
要练笔
这个是大概。
健身会是
所以因为
身体健康
不能避免，对。
哪里有？
好，
是现在都是持续了。
对，没错。
哎，对啊，你可以发一些那些东西，这么说。
所以我是有点发现吧，但是事实也可以发现，就是 representation 这个
喜欢
有些人
读个人喜欢的，你说在哪里？晚上就入口一个。
我们建议上高无限的
说法。这样你可以不喜欢，但是我就想说，你不喜欢的东西，有时候你会不。当然，你是说我很喝走这条路是可以的，但是你不要说我去避免。你可以说你 prefer， 但是如果那个东西进到你的面前，不要避免，因为就是需要。不要明白。 Okay, ready? Start. What?
1 minute left.
1 minute left, huh? Okay, 1 minute left. Let me drink water first. Enjoy music club. Huh?
3 departments in music club.
3 departments? What's 3 departments?
Vocals department, drum department, guitar department.
You?
Yeah.
Ah, okay, okay. I don't know why music got 3. What?
什么意思？Yeah. What?
Okay, so next. Oh, what the time? Okay, good question. What's the time for midterm? So let's fix on week 8. Okay, now week 8. Yeah. Yeah, right, correct. That's right. So week 10. So how about fix on Thursday? Yeah, Thursday, 2 hours. Week 8.
About it be done.
What? No, cannot. Yeah, busy week. So I mean, I give you an extra week to study. I mean, I give you feedback also, right? So Friday you give me assignment. So next week I give you back assignment, and then you have feedback, and then you study, and then we have exam. Okay. Make sense or not? Yeah, fair enough. Okay. Yeah. So okay, another thing I want you to take note is there's no more assignment until October. I think December. But there's one thing you need to do is project. Okay, please decide your project. Okay. Yeah, I think few of you already decided. Maybe I will post out those decided ones so that you guys don't clash with each other. Okay. Oh yeah. So apparatus allow was calculator, calculator, and then one is the cheat sheet. Yeah. Cheat sheet is A4 double-sided handwritten. Handwritten, cannot print. Okay, handwritten. How small you write, I don't care, but you cannot print. Okay. A4 is standard. A4 is defined, pretty standard. A4 is defined. A4 is defined. Cannot. Okay, no electronics. Okay, A4 paper.
I can print A4 in 5
What's PT?
pixel points.
What? What does that mean? No, you cannot print. You handwritten. Yeah, handwritten. Cannot print. Handwritten, must be handwritten. Okay, no printing. If you print, I will confiscate. Then you know you have no cheat sheet. Okay. Yeah, handwritten. Make sure handwritten. Last semester someone print. Yeah, confiscate. Cannot print. Handwritten. Okay. Cheat sheet is an art actually. It's an art. Let's see how good you guys made the cheat sheet. Yeah, we also have cheat sheet in Australia. Yeah. But we don't bring calculator. Cannot bring calculator. No need calculator to compute stuff. Mostly proof. Yeah. Nothing to compute. Okay. I can show you after your exam, and then we can compare. We can compare. Yeah, sure. We can compare our cheat sheet. Okay, good. So now, about curve, you have curve. We want to measure curve. Okay, let's measure curve. So let's compute what's the arc length of a curve, plane curve. Okay, we want to measure the curve. Okay, let's call it arc length. Okay, so how should I define these length? Okay, how should we define the length? So let's say we can describe our xy coordinate using two functions. Okay, and then with a finite length. Hey, it doesn't make sense if my time is infinite, right? But you can have a sum loop, but you still will get infinite line. Okay, so let's set our finite time here. So we set a finite time frame, time interval. Okay, so you know how to measure straight line, right? You know how to measure straight line? You know how to measure straight line or not? Okay, let's say your ruler can only put horizontally and vertically. How to measure this slanted line? Your ruler can be horizontal and vertical only. You cannot move, you cannot rotate. Hey, good idea. I think this is a good idea. I think it's a good idea. This is an idea we will see in abstract algebra. This is an idea you'll see in abstract algebra. This is called a symmetry. Okay, let's say you cannot do all this. You cannot do all this. You cannot move anything for now. Okay, you are very restricted. You only have horizontal and vertical ruler. Okay, so how to compute this? Okay, so what do I mean by horizontal and vertical line here? So meaning you only know about the coordinate of this line. So how do you measure length? Yes, who's anyone? No, how? Okay, so you use Pythagoras theorem. Okay, so you measure the horizontal distance and the vertical distance. So what is C here? C is square root A squared plus B squared. You know the story of Pythagoras theorem or not? No. So Pythagoras theorem grow from Egypt. So they come from Egypt. So what I want to say is mathematics come from life. So where's the life here? So the life here is in Egypt. They live around the river of Nile, right? Okay. So they need to do what? They need to grow some agriculture, or they need to how to say? Because they live around river, right? So what they do is like they do fishery, right? Stuff. Okay. So there's a lot of land. So how you divide this land? Okay, how you divide this land to so many people? Okay, you need to measure the land properly. Okay, how to measure the land properly? So you need to make sure you don't give extra inches to different people. Otherwise, people complain, right? So they come out with this a squared plus b squared equals to c. So you make sure that you have a 90 degree so that you can compute what's the length. Okay, at that time. No, I mean for the side of the piece of land. Okay, for the piece of land. So this is also how they calculated for the pyramid. Okay, why pyramid will stay like a square at the base? Okay, won't it like you see actually building a pyramid is a great process, right? Because if you go wrong a little bit, just a little bit, okay, if you just go wrong a little bit, let me show you. Okay, so let's say this is a 90 degree, right? Okay, let's say this is 90 degree, but let's say you go wrong a little bit, just a little bit only. Okay, just a little bit like this. Okay, you don't mind so small difference, right? Okay, but what if you extend it further? Okay, let's extend it further. Okay, extend it further. Right, so you can see how much different you will get from here. Okay, how much different you can get from the original one. Okay, imagine the Great Pyramid is so large. Okay, if you have a little mistake, then the pyramid will look weird. Okay, not symmetric, for example. Okay, So in Chinese, this is called what? Do you know? There's a phrase, there's an idiom or a phrase. Yes. Okay. 失之毫厘，谬以千里。Okay. Okay. Okay. Yeah. A small change will make a big difference. Okay. Yeah. So okay, let's come back. So how about irregular one? So how we compute irregular curve in this case here? What happened? Okay. What I told you last time. If you zoom in further, okay, it is really just a straight line. Okay. So in particular, we can measure part by part. Okay, we can draw a triangle a bit by a bit. Okay, a bit by a bit. So for example, let's say we can draw something like this. Okay, we can draw something like this. So let's draw a triangle like this. Okay, and then maybe draw another triangle like this. Okay, draw some other triangle, for example, like this. Okay, and then we can keep doing it. Okay, and then maybe let's make a bigger one. Let's finish it. This part here. Okay, this. Okay, am I doing something stupid? So, oh, I should go like this. It's that. Okay. Measure the side I measure is the hypotenuse. Okay, measure the side I measure is the hypotenuse. So what should I do? So come here. Here, how? Or something like this. So almost a straight line. Never mind. Okay. So what am I drawing here? Okay. So imagine if I make this triangle here smaller and smaller. Okay, can you see that this straight line here actually approximate all these the line of this curve? Okay. Can you imagine? I make this circle smaller and smaller. So I use more circle to approximate my line. Okay. Can you imagine or not? Seng. Hello, calling Seng. What am I doing here? Seng. Must get this idea. Idea is more important than what you are going to do. Okay. Okay, this will differentiate whether you are a worker or a boss. Idea is very important. Idea. So what's the idea here? Use triangle, okay, to approximate the length of my curve. Okay. If I make my triangle smaller and smaller, I can approximate my curve better. Okay. Okay, okay. Because you see, when I get this large triangle, right, you can see the difference here. You see, can you see the difference here between this hypotenuse and the original curve? Okay, so there's a difference here. But if I add more curve, then this more triangle, then this difference here will get smaller and smaller, approximating the curve. So what are we doing here? We are taking a process getting smaller and smaller and smaller, and more triangle and more triangle and more triangle. What is it? What is this idea? What's this process? Smaller and smaller, bigger and bigger. I know, more and more. Huh? What's the thing we learned before derivative? No, almost, but there's another thing more directly involved. Before you learn derivative, yeah, before we even what did you learn? No. Integration come after. Huh? Yeah, yes. Taking limit. Okay, taking limit of the triangle getting smaller and smaller and smaller. Okay. So what are we doing here? So actually this formula of L, okay, is actually integrate from A to B, okay, over times square root of dx over dt squared plus dy over dt squared. Okay. You know what's the definition of integration or not? Riemann sum, learned before. Riemann sum. You take in the rectangle and then make the rectangle smaller and smaller and smaller. Okay, so now we make the triangle smaller, 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 and smaller. Okay, so that's why the integration comes up. And then what's the side you are integrating? So that's why I say why there's a relation with derivative, because the side we are using is actually dx over dt and dy over dt. Okay. Okay, and then you can see that inside here, actually, this is close to the Pythagoras theorem. Square root b squared x squared plus b squared. But a and b here now is derivative. And then you not just square root these values, you need to take limit integration. Okay, yeah. So this is the generalized version of Pythagoras theorem. Okay, for plane curve. How about we skip the proof? I will prove it in notes. And actually, this proof are very nice. This proof is very nice actually. It involves, okay, let me show you how nice is this proof. I won't explain it, but I'll tell you how good it is. This proof is very nice. It uses the idea of mean value theorem. I think your assignment, I put a hint on mean value theorem. There's one question. Okay, so this mean value theorem is pretty important in calculus. Okay, what does it mean by mean value theorem? So it means that, okay, the gradient, okay, the gradient at ti, let me see. So if you want to compute the gradient here, okay, gradient with fti minus fti minus 1, okay, it is achieved by some gradient at other point. If your function is continuous. Okay. So let me give you some example. Okay, let me give you some example here. What do I mean by this? So let me explain this mean value theorem. It's a very important idea actually. Have you guys learned it in calculus 1, mean value theorem? Learn it, okay. So you have a continuous function, okay? So let's say you want to get a difference between, let's say here, x1, y1, and then x2, y2. Okay, you get a line joining these two. Okay, you get a line, right? Line is described by what? Yeah, no. Two material you need for a line: point and tangent. Okay. So to get the gradient, not tangent, the gradient for this line, you just take y2 minus y1 over x2 minus x1. Okay. And then how to form this line here is really just y minus y1 equals to the gradient time x minus x1. Okay. Okay now. Similarly, you can use s2, y2, x2. Okay, but they should give you the same line. Otherwise, there's something wrong there. Okay, they should give you the same line. Okay, but you know more. This is not just two random line, right? These are not two random points. These are the points on the continuous function. Okay, let's call this a continuous function f. Continuous function. Okay, so what does it mean? This means the y is controlled by the function. Okay, In particular, y2 is f of what? F of x2. Okay. And then y1 is f of x1. Okay. So the function here becomes what? Becomes fx2 minus fx1 over x2 minus x1. So the mean value theorem tells you that if your function is continuous, okay, the gradient of this line is achieved by my function at some point, okay? And then more importantly, this point occur between the 2 points you started with. Okay, you can find this gradient at some point in between x1 and x2. This is the mean value theorem that tells you. Okay, you can find some point. Why is this true? Can you think about why is this true? Why is this true? Why can you find this gradient in one of these points? Why? This is the point of the mean value theorem. So why is it true? So from this example, right, you can try and move this line around. Okay, you can try and move. Hey, really? Oh, there's 1 point at least. Okay, why is this true? Why is this true? This kind of a question you can start with, for example, contradiction. Suppose it is not true. Right. So this is a trick we always use in pure maths. You can start with contradiction first. Okay. Why is it good about contradiction? Because contradiction gives you extra condition. Suppose it is not true. I cannot find it. Okay. Meaning there's no point that I can go in this way or this way. Okay. So any problem or not if I do that? The line is the line. The line is the line. So you mean y equals to x?
Let's give an example.
If it is exact gradient, then you have the line, right? I mean, you already have your answer. Right? Yeah, so the question is, why can you find such point? Huh? Say again? Don't understand. Collide? You mean collide? Collide? Collinear? What are you talking about? Area? How?
The green
Mm-hmm.
line and the pink
Mm-hmm.
line area.
Mm-hmm. Area, yeah, area here then. And then? Sure. Then?
And the height.
Mm-hmm.
And height need 2 points
Mm-hmm.
from above and from the.
Mm-hmm. And then? Then?
You may be confused.
Yeah, I'm confused. So what? I have find the height. Okay. So my idea was, if you cannot find this gradient here, okay, somehow your curve need to avoid having this tangent line at any point. Okay. Then my claim is you cannot construct a continuous function that connect these 2 points. Because if you're gonna come back to this point, you will somehow meet this tangent. no matter how you play around with it. Okay. Yeah, this is my idea, but to prove it is a different method. Yeah, but this was my idea. Yeah. Did you get what I said? If you want to avoid at all places about this tangent line, most probably you cannot, or you cannot build a continuous function that connect these 2 points, and you cannot. You can try and draw, Okay. But to prove this is a different story. Okay, yeah. But the idea is like that. You need to at least convince yourself the statement is true first, and then you can try and prove it. Okay. Yeah, mean value theorem is a very useful tool in calculus or analysis. All right. So let's do one example. Yeah, let's do one example. Yeah, let's do one example. So we'll compute an easy case. Okay. So we go back to our favorite plane curve, which is the circle, unit circle, centered at origin. Okay. So let's do half of it only this time. So y equals to cos t, x equals to cos t, and then y equals to sine t. And then t is going from 0 to pi. Okay, let's do half of it. So what's the arc length of this curve? Find the arc length of, find arc length of C. Okay, defined by this. So do you know how to compute the circumference of a unit circle or not? What's the circumference of a unit circle? Yeah, 周长 2 pi r. But here is unit circle, right? So it's just 2 pi. Okay, but this one is half of it, so it's pi. Okay, so you already know the answer is pi. But now I tell you a new tool. Okay, the new tool is this integration here. So L equals to integrate from AB of square root dx dt squared plus dy dt squared dt. Okay, so let's check if this new tool gives us the same answer. If it is wrong, then we can just discard this tool. Right? So we need to make sure it at least matches up with previous example. So to use this tool, what do you need to do? You need to parameterize your curve. You need to parameterize your curve, okay, using t, okay, which is cos t and sine t. You need to tell me at what time, at which position, what time, at which position, okay, using t. So we're integrating from 0 to pi. In this case, what is ds dt? Minus sine t, okay, square plus dy dt is what? Cos t. Cos t, correct? Correct, yeah. Okay. But what is this? Sine square plus cos square is just 1. Square root 1 is 1. So you're integrating 1 from 0 to pi, which is just t evaluate from 0 to pi, which is just pi minus 0, which is just pi. Okay, so you got pi. Okay, so it matches up with our intuition here. Okay. Is it okay or not? This formula, easy to use. What you need to do, differentiate your parametric equation, square it, add them up, take square root, do the integral. That's all. Okay. Okay. So there's an example on a cycloid. You can try it out in the textbook, in the lecture notes. Okay. Nothing special. And you are not required to prove also. So just learn how to compute here. Next thing, so there's a exercise you can try is compute the arc length of cycloid. Okay, so one way to make this course hard, right, is to make it computationally hard. I made you do hard integral, okay? But this rarely happen in my course, okay? I don't really care about computation. What I care is about concept, okay? Yeah. Okay, one way to make this course hard is to do computational hard. But my course will make it conceptually hard. But not really much on computation, okay? Like I told you, right? My exam, I don't bring calculator. I mean, when I was studying, okay? So maybe you need some calculator in this course because you have some other computation to do, okay? So maybe some useful not to put into your cheat sheet will be some trigo identity maybe, or integral, not much I think. Okay, so you will decide. So now let's find the area under the plane curve. This is also should be reminiscing from your calculus course, calculus 1. Okay, so let's fix our plane curve again. Okay, fix it with a finite interval. But in this case here, y equals to gt. But in this case here, we also fix our gt actually. Our gt has to be greater or equal to 0. Okay, so meaning what? So this picture here, right? Okay, how do you picture this? This is really the normal picture you get. So you have your curve on the positive y-axis, okay? And then going from t equals to a to t equals to b, okay? And then compute the area here. Okay, so this area should be positive. Okay, this area should be positive. Note that we have orientation here. Okay, we are going from t equals to a to t equals to b. Okay, let's say if your orientation is from b to a, then things might change. Okay, then the area might be negative. Okay, if you go different direction. Okay, yeah. So this orientation thing is covered in Adams if you want to have a look. Okay, but we only deal with this case. Okay, we only deal with this case, positive case. Okay, going from left to right. Okay, if going from right to left, it will give you minus. If you go bottom, you will get minus as well. But left to right or right to left is also a different story. So all these stories with different orientation, with different GT is covered in Adam. Okay, we won't cover it. We only cover this case when GT is positive and going from left to right. Okay. Yeah. Okay, so from calculus 1, what do you know? Let's say this point is x1, this is x2. What do you know? You know that this area is equals to from x1 to x2, okay, on y dx. Or not? Okay, but now your position is described by time. Okay, your position is described by time. So it's from A to B on dt. So how does this y changes? Okay, how does y changes? How? Answering how? How? Okay, how does my y? How does my y? What does my y? How does my y change? Depend on t. How y change depend on t. Put the condition here. How does y change depend on t? 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 Y equals to gt. What does it mean? It's a function in t. Okay. So I tell you that how my y change with respect to t, but how my x change with respect to d? How my x change with respect to t? Ft, okay? Then how does dx change with respect to t? If x equals to ft, what is dx? Dx equals to dt. What? This is what? Integration by substitution. Dx equals to f prime t dt. Okay, so we introduce the gradient of ft in, okay, into our integral. So this is our final form. Okay, if you're gonna integrate a plane, get the area of a plane curve, you integrate over the time interval, okay, of gt times f prime t. Okay, yeah. So let's do one example. Okay, let's do some example which is useful, right? What example? Let's get the same example, right? So what's the same example? Unique circle. Let's take the same example. I don't want to do hard example because not enlightening. So how is this enlightening? Let's see. So what's the area of a semicircle? So area of a unit circle is pi. Okay, half of it is pi over 2. Okay, let's see if we get pi over 2 using this formula or not, right? So let's get this back again. Copy. Let's get the same example. Okay. Doesn't allow me to copy. Okay, maybe we just get this. Okay. Okay. Find the area under C. Okay, where C is this semicircle. Okay, we know that this is pi. Okay, we know that this area is pi. Area equals to pi. Okay, let's check using our new tool here. So A equals to integrating from 0 to pi in our case. Gt is what? Sine t or cos t? Careful, don't simply put your gt and f prime t. So what is gt in this case? Actually, gt is what? Only two choices you can make. Okay, why is it sine t? You need to put the function for y. Okay, f prime t in other words is minus sine t. Correct. Differentiate cos minus sine t. Okay, so what is this? So you are integrating minus sine square t. How to integrate this guy? Need to use double angle or not? Yes. Yes. Okay, tell me the formula. What's the double formula? 1 plus cos 2t. Everything divided by 2. Others check? Others check? Yeah, others check. Please check. If not, we just proceed first. 1 minus 1 minus? 1 minus? Okay, everyone agree. 1 minus. Okay. Okay. Okay, so let's proceed. First, if wrong, then maybe we need to come back and check. Okay, I integrate minus half, so you get minus t. How about cos 2t? So it's plus half. Cos 2t become sine 2t over 2. Okay, let's do it. So from 0 to pi. Okay, so first terms you get minus pi over 2. Sine 2 pi is just 0. Okay. And then what else? 0, 0 is 0. Okay, I get minus pi over 2. But just now say, what's the area? It's pi over 2, right? So why there's an extra minus here? Why is there an extra minus? Ah, okay, I know what's going on here. Okay, so what's the orientation of this curve? Going from right to left. Okay, this is going from right to left. But just now I discussed the condition going from left to right. Okay, so so there's really something going on. If you change the orientation of the curve, you'll get a minus sign. Okay. If you want to know more about this, you can go to Adam. Adam will discuss about this. But for the purpose of this course, if we have a question, our question is going from left to right. Hopefully. If not, you should let me know. Okay. Yeah. Hopefully we just go from left to right. Okay. But anyway, anyhow we can work it out. Okay. So why we get negative? Because the curve is going from right to left. Okay. Anyhow we can work it out. This is mathematics. Mathematics can work out all the possible cases. Okay. Okay or not? Okay. Sing okay or not? Okay, good. Yeah, if you got problem, please ask. Okay, and then the other example is about cycloid. You also can try. So the hard part is just do the integration. That's all. Formula is the same. Okay, formula is the same. So exercise, you can work out the cycloid. Try the cycloid. Okay, the next part is surface area. It's really the same how you learn your calculus one. Okay, what is surface area here? So you start with a Cartesian plane again. Let's start with a Cartesian plane. You have a line. Okay, you have a curve. Okay, so how about we don't go into this hard version of curve first. Let's start with a straight curve. Okay, straight curve. Okay, if I take this curve and then evolve it around x-axis, okay, what should I get? If I take this dx here, okay, I call it dx for now. I evolve around x-axis, what do I get? What's the object I get? Yeah, I get a what? What? What's that? The cylinder? What did you say? Cylinder, right? Okay, so we get a cylinder. Okay, so we get a cylinder here. This. Okay, then go back. Okay, we get a cylinder. Okay, so in general, right, we can take a curve. Okay, we can take an irregular curve, and then we do this evolving action. Okay, we trace out a surface. We trace out a surface. So cylinder, you know how to compute, right? How to compute the surface area of this cylinder? 2 pi r h. Okay, so what's the r in this case here? The r here is the height. Okay, so let's call this h. How about height of the cylinder? It's actually dx. Okay, so this is the height cylinder. Okay, so we are finding the surface area evolved by plane curve along x-axis. Okay, so we know how to find. Okay, we know how to find the surface area if the curve is straight. Okay. If it's not straight, how do we find it? Okay, so if it's not straight, what do we do? So the formula is S equals to integrate from A to B. Okay, similarly, we have time from A to B. Okay, and then what do we do? What do we do? So we must have 2 pi r h, right? So we need to decide what is r, what is h. Okay, so we still have 2 pi. Okay, so what is r, what is h in this case? So r here is this height here. Okay, so this height controlled by a function. Okay, y function. Okay, let's call it yt here. Okay, controlled by yt. How about the height? What is this height here? What is dx? Dx is really the length. Just now we know how to compute the length. What's the length? How to compute a length of a plane curve? Pythagoras theorem. Okay, so it's like square root of dx over dt square plus dy over dt square and then dt. Okay, so I need to do this integral here. Okay. So what I'm talking about is dx is equals to square root dx over dt squared plus dy over dt squared dt. Okay, yeah, this is what I have applied. Okay. Yeah. So if you wonder where this came from, so maybe we should go one step back first. Okay. So how we compute actually? So we can compute it using this formula here. 2 pi yt over dx first. Okay. Yeah. Why we involve this integral here? Because whenever you want to deal with these irregular shape, right? Okay, what you do is you use straight object to approximate it. So if you want to use something to approximate it, like what Seng said just now, you need to take limit. Okay, when you take limit, you are doing integration. Okay, when you take limit, you are doing integration. Okay. Let's do one example and then we will take a break. Okay, let's do one example and then we will take a break. So similarly, you can evolve around y. Okay, if you evolve around y, you swap the rows between yt and xt. Okay, you swap the row between st and yt. Okay. Okay. So let's do one example. Again, same example. Okay. This example, you leave calculus 2, you must remember is the unit circle. Okay, still unit circle. So we start with also half of it. So if I take the semicircle evolve around x-axis, what do you get? Huh? What? Football. Sure, football. So what's the object, mathematical object called? It's a sphere. Okay, it's a sphere. Okay. Yeah, sphere. Okay, so if you evolve around x-axis, you will get a sphere. So try and find the surface area, okay, of the sphere. How about with radius r now? Okay, let's fix it as r. Okay, we don't fix it as 1, we fix it as r. What's the formula? You remember from high school? 4 pi r squared. Need to divide by 3 or not? No need, huh? Okay. Trying to trick you. Okay. 4 pi r squared. Okay. So how? So what's the parametric curve we need to use here? X equals to cos t r cos t. Okay, because we want to have a varying radius. Okay? And then our t is going from 0 to 0 to pi, half of it. Okay. Okay. So let's try our example whether we get 4 pi r squared or not. So where's my formula? Get my formula out. Okay. Okay. Okay, right. So 0 from 0 to pi on 2 pi, yt is r sine t. Okay, square root of these b's is what? Yeah. This is what? R minus sine t squared plus r cos t squared square root dt. Okay. So you just get what? You just get r. Okay, you just get dt. It's double r. Okay, so you get r squared. Okay, so 2 pi r squared. Integrate 0 to pi of sine t dt. So what do you want? You want 4 pi r squared. Okay, so what else you left with? You need another 2. So you should hope that this integral evaluate to 2. Okay, so let's try this. So you integrate sine t is just minus cos t. Okay, integrate from 0 to pi. And then this is just minus 1, minus 1. Okay, what is this? This is just 2. Okay, so you get 4 pi r squared. Okay, which is what you have learned before. Next example is also surface of area revolving by a circle. Okay, you can try. But the hard part of it is just integral. Okay, yeah. Same formula. Formula is the same. Okay, yeah. Okay, any question about these 3 formula we introduced? So arc length, area under the curve, and the surface area evolving by the plane. Okay. And these 3. Okay, I think the formula quite straightforward, right? So the hard part of it is just integration. Okay, you need to recall how to integrate trigo identities, how to do part, how to do substitution. That's all. If you try out all the tutorial questions, these are the tools you need. Okay, please try a tutorial question. If you don't have time, you don't need to try all. You just try some of it to get an idea. Okay, to get a feeling. That's all. Okay, yeah, I don't want you to go into exam rules and I never seen this before. I never tried this before. Okay, so make sure you do some of it. Okay, any question? Any question? Any question? Anything wrong with the calculation? Okay. Okay, if not, we'll take a break until 5:16 and then we will come back with the fun stuff.
因为它不是，因为那个它没去，就是一个方选嘛。
parametric 不是一个方程，讲什么话？OK，也是两个方程，
它是两个方选。
两个方程，一个形容 x，一个形容 y。
啊
depend on 你呢，其实我们 parametric 可以进到 3D、4D，但是我们在 2D。
这样子，
呀
但是这种它也可以画，它也可以找出来的那个 area。
所以你要看你的 area 是什么情况哦，就是说怎么说呢？哎，给我想一下，所以OK，所以你看它的字眼是什么？看它的字眼是什么？area，看下它字眼什么啊？area under the plane curve，所以你 under 的意思是什么呢？啊，所以你可能会做的事情哦，你是会有某些地方你会算2次，因为这边是下面嘛，这边也是下面嘛，所以你这一 part 会算好几次，可能这次又算一次，这次又算一次，这次又算一次，什么意思？OK，说你看你这个 plane curve 啊，我可以拆掉它，然后我可以拆成，我可以拆成这个，我可以拆成这个 part，我才可以拆成这个 part，然后再成为这个 part，懂什么意思吗？所以我把它拆成这个部分 and then 这个部分
Yes，
and then 这个部分，你知道为什么我要这样拆吗？
因为让它变成一个方选，这样子才可以算它的一个 area。
OK，你这样讲也可以，
对
对，你这样讲对，你这样讲是对的，你这样子是对的。但是呢，你看我这样子做呢，什么情况发生呢？你看这个 part 哦，在这个 part，在蓝色这个 part 我其实已经算过它了，然后蓝色 part 的这个 part 呢，我还会在红色里面也再算到它，所以你会一直有重复的那个 area under the plank，对，就这样，
就这样。
就这样。
所以我们就是要减掉那个，如果
它有，
这样子的话，
你看。
这样子的话就很像是那种，就是这样子。
哦，它 area 是这样。
啊
Actually，你可以去看 Adam，他有这样的 example。OK，你去看那个 Adam 那本书。但是我现在可以跟你讲，你可以去看那边还有 example，他就会算到这个派也会算到，这个派也会算到。
也会算到，
对呀
这还不是一个圆柱体。
但是你看他算这个派的时候，是不是又重复到了？
Yes，
你之前也是算过。Adam 有这个图，对，Adam 有这个图，你可以去看一下。你看他会算，他会去算这个派。有可能会有这个可能性。
那我们现实上面，就如果我要算这种图的话，
什么情况呢？
那怎么算？如果还没有这个，要减掉这个，
减掉那个什么？
就是这边有一个，它因为还会算嘛，要减掉。
但是你要你是说你不是你的意思是说我要算里面罢了哈？
里面
我不要算那个哈，对不对？OK，所以你怎样做呢？你当然是要，我想一下啊，你要这个黑黑的 part，但是这个黑黑的 part，但是你要知道哦，你在算这个里面的时候，你是算到底耶。所以是说你要算里面，其实你就拿这个算到底的东西减掉这个，这样就会剩这边，对不对？呀，就这样。
对我们的那个，所以我现在的 example 都是没有
普通罢了，
普通跟这个没有关系，
没有好像这样回来一下又出去这样。我们都是这样一条路走一条路走到尾，对，因为你看你这样子啊，你又回来啊，就是刚才我们那个情况啊，从右到左，所以这边的 integral 是会 cancel 掉的，变负的嘛，对不对？所以你看你正，然后负，然后又正，然后又负。
但是它真的是存在的，不是吗？
有啊，
但是它是幅度，
又怎样呢？它只是一个方向吧，
方向啊，只是
只是方向吧。 那个负是一个方向。
OK，
Yeah.
For the when I calculate with t from 0 to 1, it's apparently going from right to left, so I get negative area.
Oh, you get negative area, is it?
Yeah.
I think so. I think so. Let me see. I think I remember there's something orientation coming out here. But seems like I think we can skip. Okay, let me check first and then I will announce later. Okay.
This reality check。如果我想去打老师，我一定有这个，就白人被老师打好，你意识到有错误了吗？意识到了，你的错误是什么？他们现在是人类吧？好，黑鬼现在是人类吧？好，哎。对，很个老师，很个老师，对吧？10点我就去很高，然后上，我以前课的，我是10号，我们那边，要和我一起吗？要。
I know.
我要照我们的课程。
Okay. Gotcha. Okay. Yeah, so Larry just now asked about the assignment question 4. You need to find the area of a curve. Okay. So there's some orientation issue there. Okay. So one way to go around it, you can use what I said just now, from left to right or right to left. Yeah, but to make your curve go from left to right instead of right to left, right? One trick you can do is change the time interval. So your time go reverse in time. Okay, instead from positive small to big become big to small. Okay, in that way you can change the orientation of curve as well. If you don't like to change your orientation of your curve, you change your integral. It's the same effect, right? You put a minus sign in front of integral. Is it like swapping the domain, right? Yeah, so it's the same effect. So depend on how you interpret the question, it's fine. Okay, yeah. This is the trick. Okay. Okay, haven't tried? Okay, let you try first and then you will come back and ask me. Okay, yeah. Okay, so this is a real difference between calculus 1 and 2 already. So we are going to do polar coordinate. Okay, let's do polar coordinate. Okay. So what we have done is we always live in an XY coordinate world. Okay, we always live in an XY coordinate world. Okay, so in this XY coordinate world, how we describe a point? Okay, Seng, how to describe a point? Yeah, how to describe a point? Yeah, how? Yes, okay, you use coordinate. Okay, so you have a x1 coordinate and y1 coordinate, for example. So this point is just x1, y1. Okay, so now we introduce another. Okay, we introduce another way to talk about this point here. Okay, let's fix this point as a 1, 1. Okay, we fix another way to talk about this. Okay, we use circle. Okay, we use circle. So to talk about circle, what do you need? You need radius. Okay, you need radius and then a center. Okay, so what are the circle we are using here? So let me draw the diagram. So we have the same plane. So this is called a XY plane. Okay, so we are working on XY plane. Okay. So there are a few things you need to differentiate here. We have polar coordinate, XY coordinate, XY plane. Okay, so you need to coordinate. You need to differentiate these words. XY plane. Coordinate refers to the position. Plane refer to the real plane. Okay, real plane. Okay, it's the real plane here. Okay, and then the axis is x-axis and y-axis here. Okay, let's say I say r theta plane. What does it mean? Then the axis here will become r and theta. Okay, so this is the difference between plane and coordinate. Okay, so polar coordinate, the other name is r theta coordinate. Okay. So I'm describing now what is r theta coordinate now. So let's say we have circle, we have a lot of circle. So in particular, we have circle with radius 0, and then maybe 0.5, 1, and then 2, and then so on. Okay. Okay. So I claim that these two will give equivalent system. Okay. So meaning even one point on xy. Okay. I can describe using the xy coordinate. I can also describe using the circle. Okay. So every point must lie in one and only one circle. But lying on one circle, there's a lot of points on this circle, right? Okay, so how you decide which point? Which point on the circle? How you decide? You need to know about angle. Okay, angle from where? You can decide but we fix from positive axis. Okay, we fix a positive axis here. So let's call an angle starting from positive axis theta. Okay, so what do I mean here? So from xy, okay, tell me a point on xy coordinate. Okay, xy plane. I can tell you which circle it lies on. Okay, can you tell me or not? For example, which circle does 1, 1 lies on? Which circle? Hey, seriously? Let's try. Okay, so what's the radius from 0? 1 square equals to 1 plus 1 or not? Is it 1 square equals to 1 square plus? No, right? 1 not equals to 2. So what's the radius here? Square root 2. Okay, so this guy here lies on a circle with radius square. Okay, center at 0. All the circle we consider as center at 0. Okay, so it's with radius 2. So let's pick one radius 2. Okay, let's say this guy is radius 2. Okay, here is 1, 1. Okay, 1, 1. How about okay, maybe a bit far, so a bit cheating, so I don't want. So let's do a similar one. So maybe this point here, okay, here, square root 2. Okay. How about angle? How to find the angle? How to find angle? How to find angle? Huh? How to find the angle? Y over x. And then tangent theta. So tangent theta equals to y over x. Right. So in this case here, theta equals to tangent, arctangent of 1 over 1. Okay, arctangent 1. What is the arctangent 1? 45. Correct. 45. 45 degrees. So here it should be 45 degrees. Okay. So you develop a way to find this. Okay. So what does it mean here? So I give you, similarly, if I give you r theta, okay, so how to find r? So just now, what did we do? R is just square root of s squared plus y squared. Okay, how about theta? It's just tangent, arctangent of y over x. Okay, so if I give you a point, I give you a point on polar coordinate. Okay, for example, what's the polar coordinate for this point? I will write it as r theta. So r theta is r is square root 2, theta is 45 degrees. Okay, so you see, one point with different name. Okay, seeing one point with different name. What are the other names people call you? Wasabi. Okay, so you are seeing, you are also wasabi. Refer to the same person. Okay, so similarly to this point 1, 1 here. It is called 1, 1. It is also called square root 2, 45 degrees. Okay, so you see, I can go from right to left. I can also go right to go from left to right. I can also go from right to left. Okay. So let's say, okay, if I give you r theta, can you find me xy or not? If I tell you the radius, I tell you the angle, okay, can you find me x and y? How? S equals to what? S equals to what? Okay, x equals to r cos theta, y equals to r sin theta. Okay, you develop a way, okay, to go between polar coordinate and xy coordinate. Okay, good. Okay, so this is how we go between these two coordinates. Note that these two coordinates are happening in the xy plane. Okay, we never change the plane. We never change the world. Just the point have different name. Okay, that's all. So what does it mean? I change my coordinate, but I don't change my plane. Okay. Okay or not? Okay, I change coordinate. All right. So some terminology you need to learn. So in this case here, what is important about this polar coordinate? So what is important is really this line here. Okay, this line here. Okay, this line will swipe out every point. Okay, if you consider all the angle, if you consider all the radius, it will swipe out the whole plane. Okay, so what do you need? So in polar coordinate, what do you need? So what you need is origin. Okay, you need an origin, and then you need a positive x-axis. Half of it is enough. No need to take the whole axis. Okay, this is called the polar axis. Okay, and then you can go infinitely long. Okay, but xy plane contain all other points in the plane, right? So what you do? You rotate. Okay, you rotate the polar axis. Okay, you rotate the polar axis. So to get the other point, you rotate it. For example, by let's say this point is PR theta. Okay. Okay. Yeah. So let's say if this is R theta, okay. So if I go the other way, okay, what should this point be? Okay, let's try and compute this, right? So we have theta here. To go from positive polar axis to the other side, we have theta plus pi. Okay, theta plus pi here. Okay, what happened in the theta plus pi? We can name it as r theta plus pi. Okay, but there's another way to name this. Yeah, so why is it equal to negative r theta? Why is this true? Try and think about it. Why is this true? Sure, you definitely have to go back to XY to see it. So how you go? How you use? How you like? How you? Yeah, how you prove this? Wait. So start from where? Okay. Cos plus pi is what? What is this value? This is the x value, right? Okay, so this is the x value. So let me, how about we draw some more line here so that we can plot this x point here. Okay, so this is the x part. Okay, then. Okay, so this is how we go about describing xy, right? So y is equals to r sine theta plus pi. Okay, good. Then, and then. Cos theta plus pi is what? Know how to remember the formula or not? Yeah, you can just derive it. Yeah, you just derive it. So you have pi, right? You move away. You move forward or backward? Back. You move to left, right? Okay, you move to left by pi. So you get this. So it's minus sine pi, minus sine theta, is it? Yes or no? Okay. So first of all, what's the formula for cos theta plus pi? Huh? Minus cosine theta. Okay, so look at this graph here. So what happened? When I put 0, right, it's already at pi. Shouldn't I get minus sine theta? Oh, minus cos, correct, minus cos. Okay, so if I move it like this, so I should get something like this. So this is a minus cos, correct? Yeah, because I have cos like this, and then to get this, I just swap around. Okay, yeah, correct. Okay, good. So, what do I get here? In our work, we get r sine r minus r cos theta equals to x. And then sine, how about sine? Again, how about moving sine by pi? Moving sine by pi, what happened? So let's have sine, okay, move by pi. Or get this. Also, minus, multiply by minus. Okay, so minus r cos sine theta equals to 1. Okay? Okay. Okay, so how about this one? Okay, from here, okay, from r theta plus pi, we get xy. Okay, how about from minus r theta? We get exactly minus r times cos theta is x, and minus r times sin theta is y. Right, so this is how we get from r theta coordinate to xy coordinate. Okay, so let me draw this. So here is r theta to xy. Okay, and then here is minus r theta to xy. But these two are equivalent. These two are equivalent. So these two are equivalent by the trigo identity. Okay. Can you see how this minus come out? So this come out because of my trigo identity. Okay. Yeah. So there's a lot of symmetry here. So I draw a picture here. So you can go from top to here, bottom to right. So bottom left to top right, or from top left to bottom right. Okay, yeah. So you can try and prove these identity. Okay, otherwise you can just use it. Yeah. If you want, you can prove it. Otherwise, you can just use it. I make a summary of this. You can have a look. Okay. Okay. Yeah. Just use the way we how we derive it just now. You just compute two number, right? Compute these two number that should give you the same xy. Okay. When they're equal on the polar coordinate, you should apply the same coordinate change to xy, and then they should agree, like what we showed just now. Any question or not? Yeah. Sometimes what I say, right, you can't see it because you haven't do it. So you have to do it. So to see what I say, you need to know what you need to do. Okay, if you don't know what you need to do, you need to ask. Okay, yeah. You know what you need to do to check? Find xy using r theta here. Okay, see that these two numbers give you the same xy. Okay, this is what we have done here. Okay, we have two description on polar points. Okay, and then we get xy from two places, and then we see that these two xy should be the same. Why? Because of the trigo identity. Make sense or not? Okay, why these two set of xy is the same? Because of the trigo identity. Okay, so all these things just use trigo identity. So did you notice anything here? Xy have two coordinates. R theta also have two coordinates. Is this accident or not? Is this an accident or not? No. Why? Why have to be exactly 2? Why have to be exactly 2 variable to control? Can I just use radius to control now? Can I just use angle to control now? Why I need 2 to describe all the point in my plane? Yes, it's about dimension. Linear algebra. Okay, SY has a 2-dimension, it's a 2-dimensional vector space. Okay, so if I change variable, I change the basis. I change the basis to radius and theta. Okay, so I need 2. Okay, and why is it only 2? Because 2 of these span my vector space, and then 2 of them are linearly independent. Okay. Yeah, so all these things are related one. It's not separate. Okay, everything's are related one. Okay. Okay, let's do some exercise, right? So let's do some exercise. Try. Okay, I want you to work out now. Okay, so try and work it out now. We still have time. So I give you 5 minutes. Work out these 2 numbers here. These 2 questions. So find the Cartesian. Also the XY coordinate, right? Sometimes we call it a Cartesian coordinate. Next time I'll tell you why it's called Cartesian. Okay, next time. So Cartesian coordinate corresponds for pi over 6. Okay, so find what is the xy correspond to this point. And then second question is find a pair of polar coordinates, okay, given an xy point. So find the radius and angle for this point here. So this point is -3 square root 3. Okay. So first question, I give you r theta, find me xy. Second question, I give you xy, you find me r theta. Okay. Yeah, try. Try. Okay, try. So let me remind you a bit. So xy in terms of r theta, what's the formula? X equals to r cos theta, and then y equals to r sine theta. How about theta, r theta in terms of xy? R equals to, remember how the square root thing come out? Square root x squared plus y squared. Theta is the tangent of y over x. Okay. Yeah. So I just need a final answer. Anyone repeat, finish, just shout out the answer. Finish xy and tell me what's xy. 2 square root 3 and 2. Okay, good. If you have different answer, let me know. How about second one? Anyone finish? Square root 3 and then about 6. Okay. Yeah, please check your answer. So, like just now, right? This point here have 4 description. Okay, there's 4 description here. So this is also equals to minus 2 square root 3 of minus 1 over 6 pi. Okay, the other description is you keep the radius the same, but you add multiple pi to your angle. And the other possibility is you keep 2 square root 3 and then become minus 7/6 pi. So these are all the same, referring to the same point. And then I will tell you why you have so many descriptions next time. I will tell you. Four description. Okay, so next time I'll tell you the story about Cartesian, and then I'll tell you a story about this polar stuff. Okay, next. Anyone have a different answer or want to object? No? Agree? Okay, pass. Okay. So next, so why are we doing this polar thingy? So why are we doing this polar coordinate? Because actually, we care about these polar curves. Okay, remember last time we said that there's some curve that cannot pass the vertical test. Okay, we cannot write y in terms of x, but now we can write this function in terms of r in terms of theta. Okay, so for example, what kind of graph we can have? Okay, so let me see. Okay, so for example, let's plot the graph r equals to 2. Okay, can you imagine what this graph is? Radius circle y. Y is a circle. Y is a circle. Y is a circle. What kind of circle? Circle need to be described with center and radius, right? So what kind of circle? From where? Okay, from the origin. Okay, from the origin. So what's the definition of circle? Do you know? What's the definition of circle? You every day draw circle. Why draw like that? Yeah, what's the definition of a circle? Huh? Not a square. Not a square, I can draw a triangle. Right, I can draw a triangle. No square, no triangle, I can draw a star. Not a star. And then I draw something else, octopus. Right. Okay, so what's circle? Circle are all the points that is equidistant from a point. Right. Okay, so a circle is what? It's a set of points that are equidistant from fixed point. Okay, the fixed point is exactly the center of the circle. Okay, so r equals to 2 means there's no restriction on theta, but your radius must be 2. Okay, and then why is the radius starting from 0, 0? Because this is the setting on our radius. I set my radius starting from origin. This is how I construct my polar axis. It's a positive x-axis. And then see, just now we cannot express this as a function, right? Because this failed the vertical test. But if I consider it in the polar coordinate, then I can write this as a function. And then this is just a constant function. Become a constant function. Yes, much more easier to calculate. Yes, correct. Okay. Actually, this is related to your integral. When you integrate x squared, y squared, right? Why sometimes you need to do trigo substitution? Remember? Like square root of some x squared, you need to do tangent inverse whatsoever. Why? That is actually changing to polar coordinate. Okay, later you will see more. Okay, yeah. Okay, yeah. Okay, so now you need to start pick up why I'm doing this, why am I doing this, why am I doing this. Okay, not just do. Okay, yeah, why are you doing this? Okay, next, how about I fix theta? Let's fix theta now. Okay, fix theta equals to 1. What curve you get? Radius can be anything, but theta got fixed. Straight line. What kind of straight line? Okay, straight line pass through origin, good. So what's the gradient? What's the gradient? So it's a straight line with angle 1. Okay, because you include all the radius. Okay, all the radius you include. Okay, so linear line still become a constant again. Okay, in polar. Okay. Usually this is a linear line, right? Y equals to what? Okay, can you compute this or not? What is the gradient of this? Tangent 1. Y equals to tangent 1 x on. Like this? Sure. What's correct or not? So I mean you can pick one point, right? Okay, what point you can pick? Maybe you can pick 1 if you like. Okay, radius 1, theta 1. Correct or not? Is it on this line? On this line, right? Okay, so what is the xy for this 1? How to go backward? Cos 1 and sin 1, good. Cos 1 and sin 1, good, very good. Okay. So how to find gradient? Sine over cos. Correct or not? Sine 1 over cos 1. Because you just compare with the obvious point 0, 0 here. Okay. Then this is really tangent 1x. Okay, yeah. Tangent 1x. Good. Okay. You change the linear function become a constant function in the polar rule. Okay. Okay. Let me see what's the next thing we should do. Okay. Okay, we should go to the next one. Okay, so we do a harder one. Okay, let's do a harder one. So R is depending on my theta now. R equals to 2 cos theta. Okay, so this one is very important. I start getting important because this is your last question in your assignment. Okay, last question in your assignment. So, okay, let's try plot this. Okay, we don't have much time now. So I will tell you the result. So let's plot a few points. So, I mean, the most primitive way to do this question is to try a few points. Okay, this is the most basic thing you should know how to do. Okay, then the next basic things you should know, without plotting this point, how I draw this curve. Okay. Have I tell you a story or not about my discrete math students? Have I tell you? Okay, let me tell you a story. So I teach the binomial theorem, right? Okay, x plus y to the power n. How to evaluate this? How to evaluate? So there's one tool to calculate it. Do you know what is it? How you like write all these truth thing in a one, how you collect these things together? Yeah. How to like systematically put these number together? Huh? What? What? What's that? What was that? What did you say? What pi over 12? No, we're talking about the expanding the binomial. I mean the coefficient. What's the symmetry in the coefficient? What's the symmetry? And then there's one way, what's that? Yeah, the Pascal triangle. So the Pascal triangle, each row will tell you the coefficient for the degree you expand. Okay. So supposedly what? You can use combinatorics, the combination to compute it. But one of the students, right? So my question is something like x plus y equals to 36. So I asked about maybe x, what's the coefficient of x 24 and y 12, for example. Okay. So what's the obvious way you do? 36, 24. You know what the student do? Expand what? No, he don't expand. Expand is even low. Even stiffer. So not expand. He wrote down the Pascal triangle up to the 36. And then you, of course, you imagine the answer is wrong. Because it's growing really fast when you go to the more than 2 digit, the Pascal triangle. Okay. Yeah, he spent like 2 pages to write it down. Okay. Yeah. But anyway, you still know there's one way to get it. Better than you don't know what to do. Okay. Yeah. Okay. So you should try this point. Okay. So what's my point here? So if I try testing all these points here, getting this choice, maybe up to pi. Okay, so what do I get here? I get 2 square root 3. So you should observe, okay, for now, right? You didn't calculate. Please observe the value for r. Okay, please observe the value of r. Can you see some symmetry here or not? Okay. So we're trying to plot these points. Okay, let's plot these points. Where's 0? Where's 2, 0? Okay, 2 is on the radius 2. Okay, and then angle 0, so meaning on the positive x-axis. Okay, this is the first point. How about square root 3 pi over 6? Okay, so maybe somewhere here. Square root 3 pi over 6. Okay, and then you increase your angle. Okay, when you increase your angle, you decrease your radius. So you slowly go in. Okay, you slowly go inside. 2, 4. And then when pi over 3, it is just 1. Okay, you go further up. Okay, and then you go back to 0 again. Okay, you go back to 0 again when you get pi over 2. 0 pi over 2. I think I swapped my order, right? So let's put it back. It's radius and okay. Hey, note that when radius is 0, no matter what angle you put, it is still the origin. Does it make sense? 0 theta is just 0, 0. Okay. Okay, you continue. Okay, so how do you continue? So when it is 2 pi over 3, you get minus 1. Okay, so actually you get this point here. Any objection on this? How I place this point? Minus 1, 2 pi over 3. Where is 2 pi over 3? Where's 2 pi over 3? It's on the which quadrant? Second quadrant. Okay, so meaning the angle is here. Okay, but why I put on the fourth quadrant here? Because the radius become minus, so you go to the opposite side. So meaning you plus 2 plus pi. Okay, remember the example we showed just now? Plus pi, you become negative. Okay, And then similarly, you can plot all the other point here. So you have a symmetry. Okay, so what I claim here, actually, you get a circle. You get a circle, a real circle, although I draw a jajak one. But this is a real circle. Okay. Okay, this is a real circle. So few things to note here. Okay, few things to note here. You see, this is a real circle, but I only use theta up to pi. Okay, I only use theta up to pi. I already cover a whole circle here. Okay, I'm not the normal unit circle. I just use 0 up to pi. I already finished this circle. Okay, this is something to note here. And how to prove that this is a circle? To prove that this is something is a circle have to satisfy a equation, which is s squared plus y squared equals to r squared. Okay, so let's see how we prove this. Okay, let's prove this. We have to check that all these points satisfy a circle equation. So what all we know is r equals to 2 cos theta. This is all what we know. Okay. So how we find x and y? So our formula is x equals to r cos theta and y equals to r sine theta. Okay, so we need to compute what is a squared plus y squared. Okay, in this case. So this is equal to r squared cos square theta plus r squared sine square theta. Okay, but my r is controlled by theta. Okay, so we need to sub it in. So 2 cos theta square cos square theta plus 2 cos square theta sine square theta. Okay. And what can we do? We can factorize. Can we factorize? So we can factorize r square first. Okay, and then we left with 2 cos theta square. Okay or not? Something wrong? Huh? What do you think? You have another way to do? What do you think? Wait. How about let me finish this way first? Yeah, let me finish this way first. You have another way to do? Yeah, yeah. Okay. So, okay, then what to do? What can we do now? What can we do now? Separate up. Separate what? Can we reduce everything back to x and y or not? How to reduce back to x and y? Right. We don't want extra. I mean, we want it to be equal to some constant, right? R squared. So r squared is what? R squared equals to 2 cos theta squared. Yeah, sure. If I put it back, okay, this is where we started from. And then r squared equals to 2r cos theta. So let me see. So r squared equals to 2. R squared equals to 2. To what? cos theta like this. Why? Huh?
Can make one of the R.
Uh-huh.
Make it equivalent to cos theta.
Uh-huh. Oh, okay. So like this. R dot R, right? So equals to. Okay. Okay, sure, good, very good. Good choice. Why is this good? Because yeah, R cos theta is X, correct. Very good. Very good. Good. Alright. Is this closed already? So we have x squared plus y squared equals to 2x. How is this a circle? Okay, so we can try and move around. X squared plus y squared minus 2x equals to 0. Is this a circle? Not yet. How is it a circle? Completing the square. So how to complete the square? 1 is enough. Okay, plus 1 on both sides first. Then x minus 1 squared plus y squared equals to 1. So this means what? This is a circle with radius 1 that is centered at 1, 0. Okay, so 1, 0 maybe here. Okay, and then this is a circle with radius 1. Okay, yeah, very good. Any question? Any question? No? Question? Hey, how just got different way to do it? Same with this one, huh? Okay. Yeah, maybe we take a bit longer step. Huh? Yeah, it's this approach. It's just writing in different order. I think, yeah. I mean, you really need to use this fact to bring out the x. Yes. Right. Okay. How about I quickly tell you what happens if I change the. Okay, let's say I change the what? Let's say I change the. I shift my graph. You can see it. This one. Okay, so if I shift my graph, okay, I can shift my graph and I can scale my graph as well. Okay, A plus minus B or A plus minus B. Okay, first one is A plus minus B cos theta. Second one is A plus minus B sin theta. Okay, instead of cos, I can use sine as well. Okay, so what happens? Okay, what happens? You go from a circle, okay, go to something like this. And this is the kidney that Juan Ye wrote this one. Okay. And then, so this how does this happen? You just shift your function, okay? And then if you shift more, and then this will become like a heart, so it's called cardio. Okay. And then if you shift more, and then you get this. I think know how plotted this guy, right? And then, and then if you shift more, then this heart here will become flatter. Okay. And altogether, these are called limaçon. Okay, limaçon means snail. Look like a snail. Snail in French. But I haven't teach you how to plot it yet. In the next lecture, I will teach you how to plot it. Plot the flower. Okay, because assignment need a flower and a limaçon. Flower, we will plot it next class. Before we leave, right, can we take the attendance first? Yes. Almost forgot. Okay. We have Guan Ye, right? Guan Ye, Yu Yuan got, Zuo Jing got, Jing Shen, Chen Jack, Ivan, Si Ying, Larry, Lu Ha, Dong Yi, Xiao Tong, okay, Xiao Tong, Zheng Kang, Yi Xing, okay, Yi Xing, Roshan, Han Wei, To Han Wei, this one don't have, Sweetney don't have, Yeru don't have, Roland don't have, Han Wei got, okay. Ethan, so Ethan, Han Wei can or not differentiate? Okay, so Ethan. Okay, so I'll see you on Thursday. Assignment will be due on Friday. Okay, I'll make announcement because I haven't covered up to area here.
Yes.
Policy, policy cannot put on weekdays. We got policy cannot put on weekdays.